Let me hold on to that. I'll feel better. Just right.
It wouldn't stick.
Oh, I see. But that's for the demon, right?
That's it. Okay, so tomorrow we'll be taking questions using various intermediation devices, Twitter feeds, and index cards, because that is being video cast and on the record, so to speak. Today, raise your hand and yell it out.
And it's off the record, so you can say anything you like.
Okay, so, Andrew.
Mr. King, kick off the discussion. Excellent talk, I really enjoyed it. When you talked about the different cost function, the risk averse cost function in machine learning, I'm going to make the craziest speculation, which I think is true, that probably 90% of my machine learning disasters have been due to structural problems as opposed to statistical
Parameters.
integration and
Yeah.
problems. Do you think there's anything between, it's another form of unknown unknowns, but,
Yes.
but this structure, do you think there's a defense against that?
Yeah, so I should say that if you go to the medical decision-making meetings, people will yawn when you ask that question. They go, yeah, we do structural sensitivity analysis all the time. So I'm saying not that it's not challenging and not interesting, but the idea of taking structural uncertainty, manipulating it, and seeing how your decision would change, your best decision, is common practice in medical decision-making. Now, I've always been intrigued by all the possible ways you can vary structure. And my guess is we haven't, as a community, as machine learning people, really explored as much as we have hyperparameters and looking at beautiful, colorful, maxima charts, what it means to do structural manipulation, especially when it comes to being guided by statistics of what happens when we put more effort into modeling and pulling back from that, trying to generalize. So I think it's a really good question.
Maybe you did tell us, maybe I just missed it, but so what'd your car do? After you just sort of let it keep going even though you saw the
There was no way I was going to let it keep going.
I thought
It was 0.99 in my mind that it would have done something weird, but it would have hit those things head on at 70 miles an hour. Like 100%, like 0.99. Let me give it possible. I have another story to tell, but I won't right now, about a human being in that situation as the barrel. And will the car stop? I'm not so sure. Let me see. No, I can't do this. It's an ethical challenge. Yeah.
Is why do we have this expectation that our machines sort of are safety 100%? Where in the human case, right? If you let my kid, who's been 2 years old, drive a car, he'd plow right into it, right? So, there's this time for humans to learn these things. And why don't we have this expectation on the machines as well, right? I mean, you buy a Tesla, you want it to work. Exactly.
Well, this is what I meant by my suggestion for a best practice on phases of rollout. So when I bought a Tesla a year and a half ago, and somewhere was advertised that someday it'll drive itself, and I go, yeah, sure, right. And then one day, one page of text, or maybe 2 pages with scroll, showed up, and it said, your car now drives itself, or autopilot mode. I said, really? And I took it out. I was just stunned. The car was like using purportedly a convolutional neural network to see the lane, and it was steering and braking, and I was just very impressed. But the car was doing very poorly at first. For example, when you're in the right lane on a highway, it would always exit. Things like that, like you didn't expect. And it would give a lot of these confidence alerts to take over, which have largely gone away now. And I've heard, again, this is anecdotal, that millions of miles have been collected, not just to generalize the abilities, but for Kirkland, Washington, for Kirkland, for that corner, by Teslas passing these areas. So why was I a phase 1 clinical trial test candidate? I should have been informed and volunteered, yes, I'll be very careful, I will give you data, but it's phase 1, not just read the 1.5 pages of text and go. So I do think that there is learning, and it's more powerful in some ways in terms of distribution of resources than a child, and it has many tentacles. I shouldn't say more powerful because it's not likely, but still we have lots of experience coming into the system, and I think there should be phases of learning.
Kevin?
So, do you think there will be a new branch of psychology that derives out of this, which is how you should interpret your human-machine interaction and how you should properly adjust your trust level? And then if you don't give it enough, you will be treated somehow?
I should say that my experience with and I'm sure surgeons feel the same way with the rise of these automatic surgical collaboration systems in the lab still, that it's like learning to ride a horse, but the kind of horse that doesn't know about walls in front of it, for example. And there's a shared knowledge that's, a lot of it's not even represented or addressed anywhere on either side or formally. There are existing fields, CSCW, look at collaboration, Human Factors has long looked at these challenges. By the way, the closest analog to research that I think is relevant to this collaborative challenge is psychology of conversation. People like Herb Clark, Gottman, and others have looked at the idea of levels of engagement, a signal, a channel, cooperation, understanding, intention, and coordination and conversation, and having multiple levels engaging at once for the red light to be on. And they talk about the back and forth of contributions in a conversation, and we take that research to physical spaces, for example.
To start, you made a sound sort of optimistic note about the idea that although intuitively safety and performance are in tension and we have to make some trade-off, that there are examples in other engineering disciplines where sometimes you get a win-win. And I'm curious about one area where we've seen some real challenges there are where machine learning systems are very much designed not to match human performance, but to exceed it. And so that the proper, and yet, they're typically judged by, yeah, I would have said that, so now you can graduate. Grasshopper, you can leave the temple. So what you're evaluating these systems against is how closely they fit expert human judgment, and the goal is to exceed that. You really sort of are setting up a self-limiting loop. So I wonder if you have any speculation about that. If you could fix that, that would be really helpful. Thank you.
I don't really have a good answer to that question. It's a good one. I think the focus of my remark and the intent was that if we can, it's more of an engineering statement, which is if we can integrate safety, how we conjure it, considerations into the design of the system, which is a theme of a lot of what Eric told us about, then we will first trust the system in a wider range of contexts of use, right? And so we'll get more value out of it, and we can also, if we design it right, his Tesla kept learning, right? He was a phase 1 clinical trial. That phase 1 is the phase of, is it safe or not, right? So he was an unknowing victim of that process, and the system was learning. So there's a challenge of kind of, you could call it recertification, which is that as it evolves, how do we know that, well, we thought it was safe, we developed a trust relationship, this is my good friend Ed here, but in 10 minutes, he's like a different person, right?
Thanks, you've met me. So there's an interesting example here actually in AlphaGo and the way that it was, AlphaGo learned to play Go, in that the first phase of learning involved studying play by expert human players. And then they used that model as a starting point for subsequent levels of training where the machine played against itself to improve beyond human level.
One more question?
Yeah, so what about measures of competency? I mean, have you thought much about how do you measure competency of a given task for a machine? And then how do you use the measures of competency to influence how much trust you put in the system, or what type of controls are instituted? You might have different levels of control depending on their competence. And also, by the way, from a contractual perspective, right? I contract with you to build me a system with a certain competence. How are you going to convince me that you fulfilled your contract?
It's an interesting question about competency that you're asking. In narrow domains like chess, there are ELO scores, which capture competency, and you see the chart of like the ELO scores over time of automatic chess and the ELO scores of humans plus the centaurs of humans plus the chess machines. And even human ELO scores are going up over time, it turns out, maybe because they're working with these interesting, bright artifacts. But when it comes to other domains, I think we have to do other kinds of work. So there's FMEA and FMICA analyses, which capture standard failure analysis and failure rates in aerospace, for example. But it might turn out that we need to come up with new kinds of indices for smartness and trust related to types of failures over time and you know, the mean time to those types of failures for AI systems. And I know that Yoav Shalom right now is trying to come up, for example, with different kinds of metrics about AI and competency and AI and its influence on society and people. And I think this question has come up on competency as well.
Last question.
I'm going to try for recapping what I've been saying. Basically, you want to be able to jointly model across sources of error and predict whether it's safe, and just like with training, great default or not do something. If it does know that it's safe on my test one, then you can do it. So if it's not safe, then you either have a fail-safe thing, something that is definitely safe, or you have a true setting. But so have you thought?
What a great summary.
Okay, so have you thought about what if it's like too complex for humans to step in? Have you thought about like maybe you can have machines that maybe are more costly, more formally verified or something, more likely to be able to handle that situation,
Yeah.
and they can step in and like how do you be able to balance the trade-offs in the case where you don't have a fail-safe and you can do and it's too hard for humans past that point?
Yeah, it's a really great question. I was just laying out a few ideas, hopefully to get juices flowing. But the idea of combining various kinds of fail-safe ideas with verified runtime verification systems that are looking and monitoring, that are joined with fail-safe approaches, that learn over time about whether they made the correct move or not. The idea of independent problem solvers trying to all solve the same problem, and when one fritzes out, the other one comes popping in and says, no, it's okay, I got it, I got you here, because they're complementary in their approach, like I showed with the portfolio of face tracking algorithms. So we have some wispy ideas about how we would do these kinds of things. We all hope for theories and principles that will go generalize, but my sense is in AI, especially with these applications we build in the real world, the devil's often in the domain details, and a lot of this won't be generalizable probably.